Every file you upload, every video you stream, every AI prompt you send feels weightless. Like it disappears into something abstract we call the cloud. But what if the cloud is getting a real address? Not in a warehouse, not on a business park, but deep in the ocean. Because as the world races to build more computing power for AI, companies are once again experimenting with underwater and offshore data centers, using cold seawater and marine energy to cool and power the servers behind our digital lives. Microsoft's Project Natick proved the idea was technically feasible, and newer offshore concepts are now being pitched around AI demand and ocean cooling. And that raises a question almost nobody is asking. If we move more of the cloud underwater, what happens to the animals that survive by sound? Because for whales, the ocean is not silent space, it is a living map. And we may be preparing to industrialize one of the last quiet parts of it. NOAA says whales and other marine mammals rely on underwater sound for communication, navigation, finding food, and avoiding predators, while human-made ocean noise is already a known conservation issue. For years, the internet trained us to think digitally: cloud storage, streaming, remote compute, artificial intelligence. It all sounds invisible, but none of it is invisible. It runs on physical infrastructure, and that infrastructure is expanding fast. Data centers already consume huge amounts of electricity, and AI is pushing demand even higher. That pressure is one reason engineers keep looking for cheaper cooling, cleaner power, and new places to build. Underwater and offshore concepts are attractive because seawater can act as a natural heat sink, and offshore wind can potentially help power the systems. Microsoft reported that Project Natick's underwater servers showed a much lower failure rate than comparable land-based servers in its test environment, which helped keep the concept alive as a serious engineering experiment. That sounds futuristic. It also sounds efficient. And maybe it is. But efficiency for us does not automatically mean safety for the ocean. Because once infrastructure goes underwater, it stops being just a data story. It becomes a soundscape story, a heat story, a habitat story. And that is where whales enter the frame. NOAA notes that marine species, especially cetaceans, depend heavily on sound underwater because it travels efficiently through the sea and supports core behaviors from communication to navigation. To understand why this matters, you have to stop imagining the ocean as empty. For whales, sound is everything. They use it to locate each other across long distances. They use it to coordinate, to navigate, to forage, to interpret the environment around them. Some baleen whales communicate in low frequencies that can travel huge distances through water. NOAA describes sound as a primary way marine mammals assess their environment and emphasizes that cetaceans use it for communication, navigation, and finding food. So when humans add noise to the ocean, we are not just making it louder. We are interfering with the medium whales use to live. That interference can take different forms: masking communication, changing behavior, causing avoidance of certain areas, and degrading what scientists call acoustic habitat. This is already a major issue with shipping, offshore industry, and other industrial activity at sea. WFS report on shipping noise describes masking of whale communication and interference with echolocation in some species, while NOAA and other marine agencies continue to treat ocean noise as an active research and management problem. That does not mean underwater data centers have already been proven to reroute whale migrations. There's no solid evidence I found for that claim. But it does mean that adding new industrial systems into the ocean should trigger one obvious question. What kind of sound are we introducing? Where and at what scale? This is where the story gets interesting. The push for underwater or offshore data centers is being sold partly as a sustainability move. Cool the servers naturally. Use offshore renewables. Free up land. Lower operating costs. And on paper, that sounds like progress. New concepts in 2026 are explicitly pitching offshore wind plus seawater cooling as a way to support AI infrastructure growth, including proposed North Sea prototypes. But the ocean is not empty real estate. It is already crowded with shipping lanes, sonar, energy development, fishing pressure, and climate stress. Agencies like JNCC and NOAA assess marine mammal impacts from offshore activity precisely because multiple human pressures can affect marine mammals in the same waters. So here is the hidden conflict. In trying to make digital infrastructure greener, we may be moving it into one of the most acoustically sensitive environments on Earth. And if we do that badly, we risk solving one problem by deepening another. Not because every underwater server pod is automatically catastrophic, but because cumulative impact is how oceans get transformed. One installation becomes a pilot becomes a cluster becomes a network. And suddenly the question is no longer, can this work? It is, what is this doing to the living systems around it? So what do we know so far? We know underwater data centers are real as an engineering concept. Microsoft's Project Natick deployed a full-scale prototype in the North Sea and studied the feasibility of subsea data centers powered by offshore renewables. Microsoft later highlighted reliability benefits observed during the experiment. We also know the concept is not yet a mature, globally deployed industry. Many current ideas are still pilots, research projects, or startup proposals rather than widespread infrastructure. The most recent coverage around AI-focused offshore systems describes prototype plans and engineering ambitions, not massive operational networks already spread across whale corridors. That matters because it means there is still time to ask the right questions before this scales. And that is the window almost every environmental conflict gives us once. Before the build-out, before the lock-in, before the unintended consequences become normal. If underwater compute expands, the issue is not just the metal capsule on the seafloor. It is the full footprint around it. Deployment vessels, maintenance traffic, power connections, cooling discharge patterns, acoustic signatures, and where those systems are placed relative to sensitive marine habitat. Those are the questions that determine whether an efficient engineering idea stays manageable or becomes the next invisible stressor in the ocean. And location is the whole game. A quiet area is not just a quiet area to humans. To whales, it can be part of an acoustic route, feeding ground, social space, or migratory passage. That is why underwater noise policy increasingly focuses not just on how loud something is, but where and when it happens. Recent marine noise assessment work emphasizes habitat-level impacts and acoustic habitat loss, especially when repeated human sound overlays biologically important areas. Now imagine the logic of the AI boom. Companies want cold water, stable access, power, connectivity, coastal proximity, possibly offshore wind integration. Those are engineering priorities. But whales do not organize their lives around engineering priorities. So the risk is not a cartoon version where one server pod instantly sends a blue whale hundreds of miles off course. The real risk is more subtle, and probably more believable. We place new infrastructure where it is convenient for data, not where it is safe for sound. And by the time we notice the overlap, the infrastructure is already there. This is the irony at the center of the story. The same tech world that talks constantly about dematerialization, virtual life, and frictionless cloud services is now pushing into one of the most physical, least virtual environments on Earth. The seabed, the offshore column, the marine soundscape. Our digital lives are not escaping the planet. They are digging deeper into it. And the pressure is coming from something very current, AI-scale compute. As compute demand rises, companies are searching for cheaper power, more efficient cooling, and faster ways to build capacity. Offshore and underwater concepts are attractive precisely because land, energy, and cooling have become bottlenecks. Recent reporting on 2026 offshore data center concepts explicitly frames them as responses to the AI infrastructure surge. So this is no longer just a weird futuristic experiment. It is a preview of a larger decision. Where will the infrastructure of AI actually live? And what ecosystems will absorb the cost? The answer is not necessarily never build underwater. That is too simple. The answer is do not scale first and study later. Because if the next generation of offshore or underwater data infrastructure moves forward, it should be designed with marine ecology in the room from the beginning, not added as a public relations footnote afterward. That means acoustic monitoring, habitat mapping, siting rules, maintenance traffic controls, thermal discharge assessment, an environmental review that treats marine sound as infrastructure, not background. That is already how regulators approach many other offshore activities. NOAA, JNCC, and marine science programs monitor soundscapes and marine mammal impacts precisely because underwater noise can change animal behavior and habitat quality even without dramatic visible damage. In other words, if the cloud is going underwater, then ocean science has to go into the design brief. The most unsettling part of this story is how easy it is to miss. Nobody sees an underwater data center from the highway. Nobody hears its full footprint from land. Nobody connects a faster AI response or cheaper cloud cooling to the soundscape of a migrating whale. That is why hidden conflicts matter. Because by the time the public notices them, they are often already built into everyday life. And maybe that is the real warning here. Not that underwater data centers have already redrawn the map of whale migration, but that we may be building the next invisible ocean conflict before we fully understand it. The cloud has always sounded weightless, but the future of the cloud may have an anchor. And if it does, we should decide very carefully where that anchor drops.